Excited to see another historic test be performed here today.
Thanks, Jacob. That is so exciting. And as you said, we have had many of test campaigns in this facility with a series of different modules for the crew module. The article we have here today is called our structural test article. And what makes it different is exactly identical to the actual flight structures that we've delivered to Kennedy and we're in the process of building up there. So it has all of the flight-like pressure vessel, the back shells, the heat shield structure. So it's a much higher fidelity model that we'll be using for this test. What it allows us to do is look at how the loads are transmitted into the vehicle and ensure that our load predictions and our margins for the vehicle are sufficient and good for our flight vehicles. So that's the difference with the vehicle we have today. Wow. And so what's next for Orion?
There is a lot going on Orion right now. It's a very exciting time to be in the program. So for Artemis 1, as you mentioned, our crew and service module have already been delivered at the Kennedy Space Center. They're in the process of getting all of their commodities loaded, so the fuels and oxidizers and all the gases needed for flight. After that, it'll move on to a launch abort facility where we actually installed the last Artemis 1 last on top of the crew and service module. And interestingly enough, the is now ready for integration. So after that, it goes to the vertical assembly building, gets installed on the SLS rocket that'll be showing up later this year, and all headed towards our uncrewed launch by the end of the year. So really, Artemis 2 is also well into fabrication. So the crew module is being outfitted with all of its environmental control and life support systems. The prop systems are being welded into that vehicle. The TPS is the thermal protection system is being installed. So that vehicle is well on its way to coming together. And the parts of the service module we have parts of our service module that actually come from Europe. It's the European service module. It's kind of the guts of our service module, the prop system, and that'll be delivered later this year. All of that follows the very similar path, gets integrated, and similar path as Artemis 1 goes to the rocket, and it's targeted for launch in 2023. And finally, we've already started fabrication and buildup of the Artemis 3 unit. So just really exciting time to be in the program. Lots of vehicles being built, lots of testing being done, and really great.
Absolutely. No, we are so excited for all of this testing and all that is to come for Artemis. So back to our Artemis test today, or our Orion test today. Jacob, can you tell us what we're going to learn from this test today?
Sure. So we actually have over 500 sensors integrated into this test article. We really split those sensors into two categories. We have sensors which are intended to measure the forces that are acting on the test article during the impact event, and we're also measuring the motion of the test article as it moves through the water during the landing. So these are really going to tell us two things. Those forces are going to tell us a lot about any risk to the structure of the test article or any components inside of it, and the motion of the capsule through the water is going to tell us a lot about what the occupants inside might be experiencing. So really with this test, we're ensuring that both the test vehicle or future Orion vehicle, as well as the occupants inside, are safe during any future landings.
That's so great. And so there's obviously a lot of preparation behind us going on. Can you tell us all that went in?
There's a lot of work that goes into preparing this test article before it gets to what you guys are going to see today. So the test article itself was developed, built, and assembled by Lockheed Martin. At its completion, it was shipped out here to NASA Langley, where we integrated all the sensors. We attached them into our data acquisition systems, hooked them onto power, sealed up the capsule, and then prepared it for testing. Actually, prior to this test, we performed a checkout test a couple weeks ago, just to make sure we were getting all the readings that we expected. Everything checked out fine, so we are ready to begin our test today. So looking forward to it.
Yeah, and we're so excited. I think the test is gonna start soon. We might have to take some questions from social media. So I hope you all have been commenting and using the hashtag AskNASA. Let's go to some questions. Debbie?
Sure.
What will be the splashdown velocity of the Orion spacecraft?
In nominal conditions, when we're actually on a mission, I think the nominal speed is about 10 miles per hour, so it's pretty slow. It can get up to around 20-25, and so it's the parachute system does a really good job as it comes through the atmosphere. There's chutes that deploy a forward bay cover, and then drogue chutes that deploy, and the main chutes deploy. So there's a series of parachute deploys that slow the vehicle down to a very safe landing speed. As far as the test today, I think it's about 16 miles per hour. Yeah, I will have to get back on the exact number, but yeah, it's somewhere in that ballpark. Looking at the specific landing speeds, we actually vary the velocity and vary the angle of impact of the vehicle in the water to try and capture all of the envelope that we need to design towards.
That's amazing. And so, what's the difference between a hydro impact basin and a sloped swimming pool?
Well, the hydro impact basin is flat at the bottom, for one, and it's also much larger. So the volume of water that goes into it, which again, 1 million gallons of water, is needed to ensure that we can test high velocity impacts into the water and basically make sure the capsule is not hitting the edges of the pool. So those are kind of the primary differences there.
And do you know, is the basin saltwater, and how deep is it?
So it is 20 foot deep, and it is not salt water. It's a mix of light bit of chlorine, but mostly just normal tap water with some chlorine in it to make sure it's clear for underwater cameras.
Not made for swimming, though.
No, not made for swimming.
So, Jacob, what is the team looking for to qualify as today's test as a success?
So to qualify the test as a success today, we want a nominal release from the hook. So we want to actually see it drop into the water. After that, as long as it pops out of the water afterwards and we get all the data that we intend to get out of the test, it will be everything we're looking for.
That's great. So Debbie.
2 minutes.
Oh, so as you can hear, we're about 2 minutes away from the splashdown test. So I think we'll keep taking some questions from social. So make sure you're still leaving those comments down below and using hashtag AskNASA. So Debbie, when Orion splashes down, how fast will it be going? Or how fast will it be going?
I think the range is about 10 to 20 miles per hour. And like I said, the parachutes do a really good job of slowing down the vehicle on impact. We also have inside the vehicle, to protect the crew, what's called the crew impact attenuation system. So think of like shock absorbers on your car, or maybe like your if you have a mountain bike, something like that. So it actually it softens the impact of the vehicle when it lands. So not only very, very smooth and not very much dynamics there.
Not getting all jostled around as they're
landing.
No.
They have very nice crew attenuation and nice cushioned seats that help attenuate that load into the crew member. Yep.
Great. And I think we have maybe time for one more question. How long will it sit in the water once it sits down? It hits the water.
The nominal recovery is pretty quick. I think the requirement is it can be there for up to 2 hours, but we actually have recovery crews on site that get to the vehicle almost immediately, extract the crew, get them back on the recovery ship, and then actually tow the vehicle back into the recovery ship for deconfiguration. And actually, starting with Artemis 3, we'll be reusing those crew capsules. So
awesome. Well, thank you. We're going to get to
thank
this
you.
test.
15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Release.
Can't get better than that.
That was amazing.
yeah, it was really cool. What'd you think?
Yeah,
How's it look?
perfect. Yeah.